Hello, everybody. Thank you for attending this week's seminar for Desco. Um, my name is, it's not changing. Hold on. There we go. My name is Jim McKeon. I'm the Desco National Sales Manager. I've been with Desco for 31 years. With me today is Jeffrey Brake. He is organizing and managing your questions. As the presentation moves along, if you want to ask a question, open your toolbar and type in the question. We're going to have two spots where we're going to stop and answer questions during the presentation. And then at the end of the presentation, there'll be another opportunity to have your questions answered. So today's presentation is on ESD carts. ESD carts are used generally to transport ESD sensitive devices, generally in an ESD protected area. We see carts that involve the use of cafeteria trays, slotted board holders. We see carts that are used for transporting and storing unpackaged static sensitive devices and properly packaged static sensitive devices. Generally, carts are grounded through an ESD floor, so this is what we're going to be discussing today. And keep in mind that we're going to be focusing largely because of time on one basic type of common cart, but all the things we talk about can be applied to any mobile equipment. And at the end of the presentation, you'll have my contact information, and if you want to have a conversation or email about carts that you have or different types of carts, you'll be free to engage me on that. It's important to note that the performance requirements and testing of carts are identical to testing an ESD work surface. Below is the excerpt from ESD S20.20 that listed the basic requirements, and you can see that work surface qualification and mobile equipment working surfaces are side by side and the material is identical. We'll be talking about testing the carts, and basically this picture is from the TR53 compliance verification standard. And the proper testing method of a cart is to put one of the 5-pound weights on the top shelf, the other lead into third wire electrical, and the reading you're getting is less than 1 times 10 to the 9th. So for those of you who do, work surface testing, it's basically identical. So first we're going to talk about the proper setup of an ESD cart before we talk about the grounding part. So we're going to talk about setting up an ESD cart without talking about wheels or drag chain, just the base cart itself. So there are several connections within a cart, and it's important that they all are electrically connected. There's the shelf to pole, there's the shelf to shelf, and shelf to shelf liner. Between those different components of the cart, there needs to be electrical continuity. For a metal cart, the typical results will be in the conductive range, less than 10 to the 4th. Unless there's a shelf liner on it, then that'll change that, but we'll talk about that later. And the maximum acceptable resistance is less than 10 to the 9th for the cart as a whole. So if you've got a cart and you think you're all set, it's important that, as we mentioned, that the entire cart has electrical continuity. So we're going to use a surface resistance meter with the 5-pound weights, and the one weight will go on the top shelf, and then you'll test top shelf to second shelf. Assuming that's good, you'll test top shelf to third, top shelf to fourth, top shelf to fifth, and top shelf to bottom. So if all of those readings come less than 1 times 10 to the 9th, then you can be confident that your whole cart is like, it's sort of one piece, okay? And that's important. If you don't get that, if you find that your the shelf resistance on one or more is too high, we find that the problem is usually found at the connection of the collar and the post of the cart. And the biggest culprit is insulative sleeves, plastic sleeves. So there are solutions for that situation, 3 basic ones. You can break down the cart and insert conductive metal sleeves. Most companies do not go for that option because it takes a lot of time and it's extremely labor intensive. You can insert a screw into the collar post, make sure that the collar and post, make sure that the screw is making connection to both the collar and the post, that it goes all the way through. And there are commercially available collar and post connectors. We sell the static dynamic collar post connector on our ESD Systems website. Many carts use shelf liners. Why would you use a shelf liner? Well, if you're putting unpackaged devices on a bare metal shelf that's less than 10 to the 4th, you're going to be really running the risk of charged device model issues with your components. Another reason is that a shelf liner prevents parts from falling through spaces in the shelf. And cushioning is a very common reason for using a shelf liner, both for physical protection and to prevent scratching if there are cases or painted surfaces going onto the cart. So the requirement of the shelf liner is the same as the requirement of a ESD work surface. You want the top-to-top resistance to be 1 times 10 to the 6th to less than 1 times 10 to the 9th. If you have carts that you've already set up using without a shelf liner, and then you decide you're going to add shelf liners, you want to go through the basic tests that we talked about and showed a few slides ago: top shelf to second, top shelf to third, etc. This testing also applies to trays, foams, and any products like that that would be possibly used as a shelf liner. It would also apply to a situation where if you have a mat like is shown in this picture, and then you put a foam on top of the mat, you need to test from the foam throughout the cart. The test needs to be performed on the surface that the static sensitive devices actually sit on to whichever you're going to be testing to. Are there any questions at this point?
We do, Jim. How you doing?
Good, thank you.
The TR53 document, that's available from the ESD Association, correct?
Yes.
If you become a member of the ESD Association, the cost is lower, right?
I believe there's no charge for it.
Oh, the TR53 is a free document too.
That's 20.20, TR53 and S541 packaging are the, I believe, the free documents.
Okay. Another question, can you further discuss what CDM refers to?
Sure.
Charge device model?
Sure. Well, there are 2 ways that ESD events occur. One is when a person has a charge on themselves, like they're walking across the carpet, and we usually think about touching the doorknob and having a shock to the doorknob, which is a transfer of heat and energy. And so if that happens to a device, you touch the device while you're charged, you transfer the heat and energy and you burn a hole in the component. The other common method is charge device model. So the device can have a charge induced onto it. Generally, a general situation is that some plastic ungroundable charged plastic is in very close proximity, and that charge is induced onto that device. So while the device has a resting charge on it, there's no problem with ESD events. An ESD event will occur when the device touches something and discharges. So the reason that work surfaces have a resistance between 1 times 10 to the 6th to less than 1 times 10 to the 9th is that it's been determined that if you put a charge device on a surface of that resistance, it will take the charge off really fast, like nanoseconds, but not too fast. But if you take a charged device and touch it to something metal, something that's conductive, it will take the charge off too fast. It's actually picoseconds, but it takes the charge off too fast, creates a spark, invisible spark, I guess, for lack of a better word, and that creates an ESD event. So one of the most common #1 rules in ESD is don't touch your devices to metal.
Gotcha. Or a conductive device. So that's why we use dissipative work surface materials.
Correct.
Okay. That's it for questions right now. Let's go ahead and continue on here.
Okay. So now we've got our cart, top shelf to bottom shelf, all electrically continuous connected. So now we're going to talk about grounding of the cart. And when there are more connections, now different connections that we have to talk about. There's the connection of a shelf or the cart in general to a drag chain. A drag chain or a wheel, an ESD wheel caster to the floor. And what's important is that whichever system you're using, that it needs to have that proper connection to ground. If you have a, again, we're going to talk about testing a cart. Now we're talking about a cart that's got, let's say, a drag chain. And you're an ESD coordinator and you decided that today is the day you're going to go out and test all the carts. So the test that you're going to do is the cart with the 5-pound weight. The lead goes into third wire electrical. You do the test, and if your reading is less than 10 to the 9th, you're done. You don't have to test anything else. If you're higher than 10 to the 9th, then you've got to figure out why. And these are the processes that we recommend going through. The first thing you need to do is test the RTG of the floor. And the test for the floor is a very simple one weight on the floor and the other lead to third wire electrical. And you're looking for a resistance of less than 1 times 10 to the 9th. Let's assume that the floor is good. Now we got to look more carefully at the cart. So the first test that we'll do is test the resistance of the drag chain from the cart to a point on the drag chain. So we're looking to verify that the drag chain itself is got a low resistance and that its connection to the cart is good. So you can take a 5-pound weight, put it on the cart, take an alligator clip it to the other lead, clip it to the drag chain and lift it off the floor. And you're looking for less than 10 to the 9th. Sometimes the connection of the drag chain to the cart might be loose. There could be oxidation. You know, when you look at enough of these, you can see a lot of things, but that's the first troubleshooting test that we want to do. The next one, again, we're looking for the resistance from the cart to the floor to be less than 10 to the 9th. So we're going to test the resistance from the bottom shelf to the floor. And that involves obviously 1 weight on the bottom shelf, 1 weight on the floor. We find in this scenario that we're describing, many times we'll find at this point the cart being out of spec. greater than 1 times 10 to the 9th. In this particular cart, it's just over, as you can see in the picture. So what we do to verify that is to repeat that test. We put one weight on the bottom shelf, one weight on the floor. We grab the chain with one hand and put the palm of our other hand on the floor and have someone else test. And pretty much on a high percentage of times, we find that this test provides a passing reading. And when we let go of the chain, you'll see that the reading goes up. So what's going on here? What problem did we just identify with that chain and grabbing the chain palm on the floor test? Well, we identified that the drag chain is either too short and or too light, and the connection to the floor isn't enough. By grabbing it with your hand and by putting the palm of your hand on the floor, you're creating a connection that's a much more thorough, much stronger connection between the drag chain and the floor. So what is the industry requirement for a drag chain weight and length? There is no industry requirement for length and weight of drag chains. What other factors come into play in drag chain and floor setup? Well, one of the reasons that there is no spec on drag chain length and weight is that the lower the resistance of the floor, the more likely it is that your system will work. So you could have a drag chain X on a cart, and you put that cart system on a floor that's 10 to the 8th, and you get a reading. And then you move the cart, same drag chain, to a floor that's 10 to the 4th, and you're going to get a lower reading because of the lower resistance of the floor. So there are so many options, there are so many variables in flooring and drag chain length that it's really not possible to specify one size, one weight. The design of the drag chain comes into play. So, drag chains, there's all kinds of different drag chains out there. So what we recommend when we find this drag chain problem is to get a drag chain with a that's heavier and longer, so it's making better contact with the floor. We recommend a hammock setup. So this is a hammock setup going back to front of the cart, and usually we see more hammock setups that are going the length of the cart. We also see sometimes carts with more than one hammock setup on it. But one of the things that's really important is that when you've identified that you've got a drag chain problem and you decide to go with a different drag chain, what I usually recommend is go to Home Depot or like store, get a drag chain that's heavier and longer. Don't buy a lot of it, buy some, bring it back, set it up, try it and test it. Then if it works, then you can go buy some more. But it definitely can be a trial and error process, and you'll have to find yourself what works and what doesn't work. Behind drag chains, probably ESD wheels and casters are the next most common way of grounding metal carts through flooring. So the requirements are basically the same. The resistance requirements are the same, less than 10 to the 9th, and very similar tests will be performed on a cart that's failed that's using a drag chain. So the first thing that we would do in a cart that failed high resistance would be and again, we know that the shelves are all properly connected. Test the resistance of the shelf to wheels, and we're looking for less than 1 times 10 to the 9th. Then we're looking for the shelf to the floor. And again, we're looking for 1 times 10 to the 9th. This one is 10 to the 8th. Resistance of wheels alone. If you have a 2-point probe, that's a good tool to use to test this. And generally speaking, if you're getting mixed results, you're really going to want to look at the cleanliness of your wheels and the floor and decide if you need to increase your maintenance, particularly on the wheels, and depending on what kind of floor you have. But that's where the, like I said, the issues we find are usually at the drag chain or wheel against the floor stage. Any questions?
Sorry, we do have some questions. I'm typing some responses or clarifications with a few people, but let's first ask. First question: there are pre-configured ESD carts available on the market too, like from Metro and other manufacturers, right?
Right.
And those would meet. They would be less than 10 to the 9th typically, right?
They should be,
well,
yes.
Yeah, and that would be, but they still need to be verified as part of an ESD control program, right?
Absolutely. I think that no matter what ESD product you're purchasing, it's always best to buy it from a reputable source that's done good product qualification testing, but you should always test whatever it is that you're buying. We do, not so much in carts, but we do run into situations where the conversation becomes, well, it said it was ESD, and it's not. The other thing is that, if I could, that scenario you just described is particularly important if you buy used carts, because what we see fairly frequently is companies buying used carts, and they're not aware enough about the collar, and there are insulative collars in there rather than conductive collars. So we see that fairly frequently.
Gotcha. There's actually a question too. We evaluate carts as part of our ESD surveys, right? The Desco reps have this equipment, and they can do the test and the evaluation that's being described here, correct?
Absolutely.
Let's see. One more question. I know you're going to get to this, so let's leave that for later. Let's go ahead and continue on here. We might come back to these questions at the end here.
Sure.
If not, we'll answer them by email, because I want to get a clarification before I answer what they're asking here. So, okay, let's keep going. Thanks Jim.
Thanks. So everyone attending this will be receiving a copy of this presentation. So I'm not going to read this. And this is kind of a closing word on carts and drag chains. It's very unusual for the ESD Association and any of their standards to kind of give you a warning about things that people use that don't always work well. But if you look at the bottom here, it says drag chains cables have been known to be unreliable for grounding equipment. So that's just something that I think is worth pointing out, and it's important that you pay attention to it to make sure that your system is working. So when we talk to a lot of companies and they have drag chain problems or flooring problems, and they get frustrated, and so sometimes they'll ask about or wish that they didn't have to deal with that. So the ESD Association in TR 20.20 does provide a process for you to transport and store your products on an ESD cart without an ESD floor. And this is the exact verbiage from TR 20.20 here, but I'm going to talk a little bit about it. So to do that, your cart must be electrically connected. First shelf to second, first to third, first to fourth. And if you're pushing the cart around, so we're talking about now pushing a properly electrically connected cart, and you're pushing it around on an ESD floor. So the person probably is building up a charge when they're walking, handling the cart. So the person in the cart are sharing a charge. So the cart, the devices on the cart, if the charge goes from the person to the post to the shelf to the mat, in, whatever is on there into the device, then the device is going to have a resting charge on it. But nothing is going to happen to that device until there's an opportunity for a discharge. So you could have a cart, you're pushing a cart, no ESD floor, you push it out, you leave it in the middle of the production floor. Nothing's going to happen to those devices unless someone touches them. So in this system, the number one rule is that you cannot touch the devices until that are sitting on the cart until both the operator and the cart and work surface are connected to the ESD grounding system prior to loading and unloading from the cart. So this picture is a good example, and we see this a lot where a cart of some sort is there's items on it, and then the next stage is it needs to go to a workstation. So if you you push the cart over, it's got a charge on it, everything's got a charge on it. If you ground it we're using one of those static dynamics clips and a cord that's got the double banana, and you ground it to this bench mount ground here, then as soon as you attach it, everything on the charge on everything on the cart goes away, and now you've got no charge on anything there. The person puts their wrist strap into the other jack there, and now you've got no charge on the cart, no charge on the person, and then you can work as much as you want. One thing I'd like to mention about this, we've talked a lot about the continuity of the cart, and this is an example of why it's so important for all the shelves to be connected. Because let's say that you were using this method and the middle shelf was isolated. There's a chance that would have a charge on it that couldn't be discharged, and then you'd have charge devices on that shelf being handled by a grounded person. So usually what happens when we discuss this option, the big drawback is that companies are skeptical or concerned about being able to have the operators be disciplined enough to never touch a device on a cart unless it's in this scenario here that we are looking at. But I just wanted to make it known that that is possible to do that, and it's endorsed by the ESD Association. Last chance for questions.
Okay, we have, I'm going to kind of break these because it's a lot of scenarios. And one of the things with carts I know is that there are a lot of different scenarios. So the first one is if you have a properly grounded cart, let's say, on a conductive floor, and it's been tested and everything's fine, you're less than 10 to the 9, and you're transporting ESD sensitive devices on that cart, do you need to use a Faraday cage type of container for those devices?
Absolutely not. Two basic rules of thumb for ESD are things need to be grounded or things need to be packaged.
So if it's properly grounded, we don't need to be using a Faraday cage. But if we're not properly grounded, like say those carts that you showed at the end there, because those carts can't ground through the floor, correct?
Correct.
So they would need to, if you were transporting an ESD sensor device on those carts, you would want to have them in a shielding container.
Okay, so there'd be there's two possible answers to that question. So you're going to have an ESD device on a cart on a non-ESD, that's not grounded, and you're going to push it around. If you're not going to set it up the way that we described, then you need to have it packaged. So
Okay.
if you're gonna follow that process that I just described, then you don't need to package it. But if you're just saying, okay, I don't want an ESD floor, I don't want I don't want a drag chain, I don't want any of that, but I want to make sure that my product is protected without using any thought of ESD measures, put it in a bag, put it in a box, package it.
Gotcha. This is just it's not really a question, it's more of a comment, but maybe I'll talk here too. One of the question, it's basically asking about dust, grime, oxidation, other things that affect the resistance readings. And I think the point would be that you can have a perfect ESD cart, you can have an ESD floor potentially, you can have conductive casters, wheels, but you can still be in a situation where you might not be getting an accurate ground, right? And that's why you need to verify periodic verification of carts, because
Correct.
you have a buildup of dust, or potentially something else that's causing. We see ESD floors get dirty, get above that 10.8, 10.9 range, right?
Right.
So if they're not properly being maintained, then you can have a situation where you're not getting a good path to ground too, right?
Correct. I would say that by far, the drag chain too short and too light is the #1 problem that we see. But another common problem, as you went to oxidation, Jeffrey, is not a good connection for the drag chain to the cart. And whether it's loose or whether there's an insulator in there or oxidation or something like that. Definitely.
Exactly. No, so that makes sense too. There is a question about monitoring carts, and the picture there in the upper left actually is using a monitor, but that's so it's monitoring the surface, and it's connected through the power strip to ground there. So it's a kind of a special type of monitor. So it's a monitor that it's not a special monitor, but it's a special application for a monitor. It's a monitor that's used typically at a workstation, but in this case, it's been adapted to be used with a cart here. So that's effectively the hard ground method that you talked about at the end there, and a way to use a monitor for that.
Sure. So this is representing, correct me if I'm wrong, Jeffrey, but this is like a mobile workstation.
Yeah.
And this person could take this workstation, it'd be considered mobile equipment. He could take that and move it across the floor. He'd have to unplug it and plug it back in.
Correct.
But we were talking about this yesterday. You could actually put this on a cart, and then, like we've been showing, and then plug it in and run, work on the cart, as long as everything stayed on the mat.
Gotcha. Yeah, that's what I think that's what the question was. There's another, just to reiterate, there was another question about how long drag chain should be, or what again, it's not, there's no defined spec for that kind of stuff. It's really a matter of making sure that it meets that less than 1 × 10⁹, right?
Correct. It's a little bit like ionization. There is no spec saying your ionizer has to be this far away from things, because each individual case is different. And in the case of this, it's different floor resistances, different attachment mechanisms to the cart that are going to cause an influence and limit the different types of options. But you've got to set it up, test it, and keep setting up and testing until you find something that works.
All right, I think that's probably all the questions we can answer here. If we didn't answer your question directly, we will follow up with you in an email. Jim, I think the next slide has your contact information too.
Right.
So if you go ahead.
Well, if you have any questions about the carts, or as I was saying, we really only talked about one type of cart, but we can do some kind of a virtual thing, take a picture of your cart, and or, you know, we can do that kind of thing. And if you want to discuss your individual situation, please feel free to call me or send me an email.
All right, Jim, I appreciate it.
Thank you.
Thank you.
Thanks, everybody.
All right. Thank you, everybody, for joining us today. We'll have another webinar next week at 10 a.m. So we'll see you then. Bye.
Okay.
Hold on. Let me shut this down.